Alrighty, so we are going to do today's section 20-2, which is called the converse of the Pythagorean theorem. So I just want to write down a little reminder what Pythagorean theorem is. So this is just a review from our lesson from Thursday. I hate writing out the whole word of Pythagorean theorem, so you guys will notice that I abbreviate that quite often. So remember what Pythagorean theorem says. Pythagorean theorem says that if we have a right triangle, and I've designated my not so perfectly drawn triangle as a right triangle, that we have what we call legs, the two sides of the triangle that come together to make the right angle, and a hypotenuse, the longest side opposite the right angle. So Pythagorean theorem says that if we take leg squared plus leg squared, it is equal to the hypotenuse squared. And most people have seen and heard it. I mean, even if you were to ask your parents, do you remember Pythagorean theorem? They might not remember all of the details of it, but if you were to start rattling off a squared plus b squared equals c squared, they'd probably be like, oh, I remember something like that. It has to do with triangles. So it's this squared relationship between the three sides of a right triangle. Well, there's 4 specific details that we're going to address in this lesson. The first thing I want to talk to you about, and so I'm going to label this as number 1. How do I know if 3 lengths can build a triangle? So I'm going to draw with a ruler a little example. So let's say, and you guys are just going to sketch this, so don't stress about having a ruler with this. Let's say that I start to draw the length of a triangle so that it is 1 inch long. So just give me a little length, call it 1. And then I draw another length of that triangle, and I'm going to make it 2 inches long. So I'm just going to connect it. And I'm not trying to say that this is a right angle, because I think we can all agree that is not 90 degrees. So I've got one length, that's one side of my triangle that's 1 inch long, another that's 2 inches long. Can I have the third side be 6 inches long? Will that work with the triangle? Will the other 2 little sides ever stretch out to be a total of 6 inches long to make that a triangle? No. I cannot make a triangle with sides of 1, 2, and 6. It's not going to work. It doesn't matter how I try to angle that or change it or reconfigure it, it's not going to fly. So without having, I should pause, let you guys have enough time to write down. I'm used to talking to my salt and pepper shakers. They don't write anything down. So without us grabbing a ruler and drawing these, because what if I had 27 inches? I don't want to deal with 27 inches and a yardstick and things like that. So without having a ruler, how can we determine if 3 lengths will create a triangle? Well, here's the deal. To build a triangle, doesn't have to be a right triangle, it's any triangle. The sum of two sides has to be greater than the third side. And so I'm going to show you why this triangle can't be built using these three lengths. So notice what I'm writing down. I'm pairing together all combos of two sides at a time. So we had a 1, a 2, and a 6. So I'm going to put together the 1 and the 2, the 1 and the 6, and the 2 and the 6. Any given pair of sides. Okay. 1 plus 2. That's 3. Is 3 greater than 6? No. 3 is not greater than 6. As soon as any two sides aren't bigger than the other side, it's a no-go. I don't even have to keep going. It's not going to work. Flat out, not a triangle. So my next question for you, do these lengths build a triangle? I'm going to give you the numbers 3, 4, and 5. And so here's what we have to do to check. Let's take 3 and 4. That makes 7. 7 is greater than the other side. That works. That makes us happy. So I paired up the two little sides. Now let's pair up the middle and the big side. 4 plus 5 makes 9. 9 is greater than the other side I didn't use yet. 9 is greater than 3. Hey, we're coming along. If we add together two sides, that has to be more than the third side. So I paired the 3 and the 4 and the 4 and the 5. I need to pair the 3 and the 5. So the little and the big. That's 8. 8 is greater than the other side. So the answer is yes, we can form a triangle. Are we good so far? Okay. Now the next thing that I need us to write down, and if I'm going too fast, let me know. I'm kind of out of room, so I'm going to flip my paper over. I'm going to label this as part 2. If we have a triangle, how do we know if it is, and then I'm going to take some lines and some space, a right triangle an obtuse triangle or an acute triangle? And so I drew a little bad sketch of a right triangle. We know it's going to have a right angle. Do you guys remember what obtuse angles look like? And you can show me with your hands. Like, that's a right angle where I put my palms together and try to make it 90 degrees. Do you guys remember the difference between obtuse and acute? So can you show me with your hands what an obtuse triangle looks like? Don't hurt yourselves. An obtuse triangle is going to have an angle that's really big. It is more than 90 degrees. An acute triangle, I always remember it like this. It's a cute little triangle because it's got this itty bitty little angle. So let's jot that down. An obtuse triangle, and I'm going to make it like really obvious, has an angle that is more than 90 degrees. So one angle greater than 90 degrees. An acute triangle, and I'm going to draw this cute little like equilateral triangle, has all angles less than 90 degrees. So it has these teeny tiny angles. Well, this actually comes from Pythagorean theorem. So off to the side, I'm going to help you guys figure out what types of triangles these are. If it's a right triangle, Pythagorean theorem works. If it's a right triangle, c squared is equal to a squared plus b squared. Guys, that's Pythagorean theorem. I just flipped it over. Kind of read it backwards. If it's an obtuse triangle, c squared is greater than a squared plus b squared. If it's an acute triangle, c squared is less than a squared plus b squared. And if you guys need a little bit of a helping reminder, I'll remind you what those symbols mean, greater than and less than. Just going to put it in a box off to the side. If you don't need to write that down, you don't have to. Ready? So our task now, and I'm going to scoot this up, is to say, oops, that S so far away, is the triangle acute, right, or obtuse? I'm not going to draw the triangle because the way I draw it might give you a clue, and you can't go based on the picture. You have to go based on what the numbers tell you. So I'm going to give you an 8, a 6, and a 10. And so these are the 3 sides of a triangle. And there's really only one identifying thing that matters. We have to identify C. Now in Pythagorean theorem, C is the hypotenuse. That has to be the longest side. So I'm not saying this is the hypotenuse. I'm saying we're going to treat C as the longest of the 3 sides. So we're going to take the 10 squared and we're going to put it on its own. And then we're going to take the other 2 sides and square them and add them together. and we're going to put a question mark in between the 10 squared and the 8 squared and the 6 squared. We're going to compare the biggest square to the other two squared and combined. The sum of the other side squared. So I'm going to do some quick arithmetic for you. 10 squared, I think that's 100. 10 times 10. 8 squared, do you guys remember what 8 squared is? 8 times 8? Thank you, 64. 6 times 6, what's that, guy? Okay. If you don't know them, it's totally okay to use a calculator. I'm not going to take that away from you. And 64 plus 36, that's 100. Hey, they're equal. So the biggest side squared is equal to the sum adding the square of the other two sides. If they're equal, we call this a right triangle. Sweet. They're equal. It's a right triangle. Boop, boop. We're done with that problem. Did I check to see if it was a triangle to begin with? Should I have maybe done that? Real quick, 8 plus 6, that's 14. That's bigger than the third side, right? 6 plus 10, that's 16. That's bigger than the third side, right? 8 and 10, the outside, that's bigger than 6. Might not hurt to make sure it's a triangle before you go through it. Okay. Let's do another example before I ask if you guys have questions. Let's do one more. Let's do 6, 8, and 9. So same question. Is it acute, right, or obtuse? Now let's pause for a second. Is it a triangle? Well, 6 plus 8, that's 14. That's more than the number that I hid. 8 plus 9, that's 17. That's more than the number that I hid. 6 plus 9, that's 15. Yeah, we're good. Okay, so it is a triangle. So let's find out what kind. Pick the biggest side. That's 9. Square it. And give yourself some space. And find the sum of the other two sides squared. So square them and add them. So I'm doing some arithmetic for you. 9 squared is 81. 6 squared, 36. 8 squared, 64. 36 plus 64 is 100. I think we can agree 81 is not the same as 100. So I can't slap an equal sign here. 81 is less than 100. So I need to put a less than symbol right there. And if you're like, I can't always remember those less than things. The little point is always pointing to the smaller number. Some of you guys learned it was an alligator and the mouth eats the bigger number. However you learned it, go with it. I've taught it every possible way you could think of. This is less than. So the longest side squared is less than the sum of the other two sides. Less than, that's acute. We have an acute triangle. What questions do you guys have on that? For my in-person people, let's do a quick thumb check. Thumbs up, I think I got this. If we can do the arithmetic right? Thumbs on this side, I need a little more. Thumbs down, I want to work one-on-one. I am seeing many happy thumbs. If this 81 had been bigger, could we agree that we would have chosen obtuse? Do you guys need any more examples on that? No? Okay. There will, I am going to give you one more example. Just bear with me. You're going to see why I want to give you this one more example. And I don't know what the answer is. I'm just pulling one kind of from a different example source. So last example. So we're going to do a 7, a square root of 22, and a square root of 122. Weird. Do you guys see why I wanted to do this one? That looks way different than the other problems we've done. Just because it has roots on it. Okay, no worries. So, I don't really know what the square root of 22 is. I know I'm a math teacher, but I'm not a human calculator. So I'm going to walk us through finding what the square root of 22 actually is. So on this calculator, my square root is in blue. So I have to hit the blue second button and then my square root symbol, and now it's waiting. The square root of 22 is about 4.7. And the square root of 122 is about 11.1. The reason I'm doing this, I'm not going to use the decimals because I rounded way too much. I chopped off a ton of numbers. I just need to know which one's my biggest of the three sides. And I don't know what the square root of 122 is, so that might help me in my processing. Square root of 122 wins. That's the biggest. So we're going to put that on its own, and we're going to compare that to the sum of the squares of the other two sides. So you're going to see I'm not using the decimals. I use the decimals to help me understand what's the biggest, longest side. But after that, I have to use the exact values I've been given. So my question for you guys, do we know what the square root of 122 squared is? Do you know how that works? Do you guys remember from Thursday with Pythagorean theorem that square roots and squares wipe each other out? Let's try to get that to focus. That the square and the square root wipe each other out, and out comes the 122. It's not scary hard at all. 7 squared, that's 49. The square root of 22 squared, the root and the square, it's like add and subtract. You've undone it. Drops out at 22. 49 plus 22 is 71. That means 122 is greater than 71. If the longest of the three sides when squared is greater than the combo of the other two squared, we have an obtuse triangle. We just had to use a calculator to help us know, okay, which one's the longest of the three lengths? Because that might not be something we can process quickly. So to my in-person people, questions on that exam? You guys ready for your assignment now? Make this happen? Okay, I'm gonna stop my video.